Advanced Math, Lesson 61, Single Variable Analysis, Normal Distribution, Box and Whisker Plots. Let's start with variance and deviations. So single variable analysis is just data from a single source, like test scores are a good example, or if you wanted to weigh everyone in the class, everyone's weight would be a single variable. Everyone's test score would be a single variable. It's different from the experiment data plots because we're not measuring, what happens in an experiment when we put in 5 grams of carbon and we want to know how much sodium is produced or something like that. So that would be 2 variables, the 2 variables being the carbon and the sodium. In this case, we're doing single variables like test scores. So we'll go ahead and use test scores, and then we'll talk about variance range. Let's say actually they're using weights of dogs. This will be a little bit faster. So in the problem, in the book, they weigh 4 dogs. The first dog weighs 4 pounds. Next dog weighs 9 pounds. Next dog weighs 7 pounds. Last dog weighs 20 pounds. First thing we're going to want to do is we want to sort our data in order. We can either go greatest to least to greatest. Let's go least to greatest. So 4, 7, 9, 20. All right, so those are our 4 dogs. And then we got to find the mean or the average, right? So the first thing we're going to do is we're going to find the average of these 4 points, or these 4 weights, which is we add them and then divide them by 2. So I'm going to, whoops, we're not ready for that yet. So 4 plus, why am I multiplying? I should just do this in my head. 4 plus 7 plus 9 plus 20 comes out to 40. Divided by 4 gives us an average weight of 10, or our mean weight of 10, right? First thing we're doing is that. Then we want to figure out the deviation. So as far as a box and whisker plot goes, we would draw a line, and in the very middle would be our mean of 10. So we would say 10, and that is our mean, right? Now let's keep going as far as this data. We got to figure out what the deviation or the variance is. In order to do that, we're going to do a similar problem here, which is we're going to test the distance of each of these points to the mean, or pretty much do the mean minus each of those distance. So for variance, I'm going to take the mean number of 10, subtract 4. What do I get? I get 6, okay? So I'm going to take that number, I'm going to square it. I'm going to add it to the distance of 10 minus 7, which is 3 squared. And again, these are absolute value distances. I'm not worried about positives or negatives because everything's getting squared anyway. From there, 10 minus 9, I get 1, so added to 1 squared. And then 10 minus 20 is 10 squared. Because again, I'm doing absolute value. I don't care if it's a negative 10. It's going to get squared anyway. So what I'm going to do is I'm going to take all these numbers, square them and add them, and then divide them by my number of 4, and that's going to give me the variance. So let's go ahead and do that really quick. If I take 6 squared plus 3 squared plus 1 squared plus 10 squared, I get 146 divided by 4, 36.5. All that equals 36.5. So my standard variance is 36.5. Now you'll notice this number 36.5, our variance number, is way big. If we look at our original data, none of these numbers are 36.5 distance away. That's why this is called the variance number. This is not our standard deviation. To find our deviation, we take the square root of the variance. So our deviation is going to be the square root of 36.5. So again, calculator. And you'll notice for statistics, we use a lot of calculator. We use our calculators for just about everything in statistics, and that gives me an answer of 6.04. So my actual deviation is 6.04, and that's going to be the standard deviation of this graph. And oh wait, they don't want us to graph this one. They just want us to find the deviation. Oh, that's the next problem. That's distribution. Okay, so I guess I didn't need to draw this little line, but our answer here is the standard deviation is 6.04. So when they give you data and they ask you to find the standard deviation, 1, find the mean. Once you have the mean, get the distance or the absolute value from the mean, square that to get the variance, and then the square root of your variance equals your deviation. All right, next problem. Okay, next thing, stem and leaf plots. I know this is box and whisker. This is not a box and whisker. This is called a stem and leaf plot. This is just a good way to organize data to where you can read it quickly. That's something that they'll have you do in your homework. So they give, here in this example problem, they give us, why is this out of focus? So they give us this group of 32 test scores, and they want us to make a stem and leaf plot. The way a stem and leaf plot works is you just separate the numbers by tens digit and ones digit. So here we'll see in this first stem and leaf plot, our test scores range from the 50s all the way to the 90s, right? So the first column is going to be the stems, right? So we have numbers that start with 5, numbers that start with 6, numbers that start with 7, numbers that start with 8, numbers that start with 9. So your stems are going to be like your tens values, right? And you only have to put them once. We've got 1, 2, 3, 4, 5. We've got multiple numbers that start with 9, however we only put the stem once. Now the leaf is going to be all the variants in that. So the leaf is the different versions of 9s we have. The first one is 90, which we see. The next one is going to be a 96, we see there. And then next one will be a 95, we see there. So what they're doing here is they're organizing all the data from stems and leaves. So here we can see very quickly, I had one score that was in the 50s, that was a 55. We had 1, 2, 3, 4, 5, 6, 7 scores in the 60s. We had a 60, a 69, a 68, a 65, a 69 again, another 60, and a 63. Right? So stem and leaf plots are great ways for organizing data. And it helps you see, about where most of your data lies. And from here we can see, based on the stem and leaf plot, most of the scores are 80 or above, which is good news for that class, right? And so that's how you organize a stem and leaf plot. Now, the box and whisker plot is next. This is what we call a box and whisker plot, and the box and whisker plot is broken into fourths. That's what I was trying to draw in the previous problem. So for example, the box and whisker plot does not care about the mean, it cares about the median, right? So again, the median being the middle score. In this case, for the data they gave us, there were 32 numbers, and the two middle scores were 80 and 83. So the median would be 81.5. Right? That's going to be the middle of the box and whisker. And that's something that you calculate. So you would organize the scores in order, you figure out what the very middle score is, that's your median, so you draw this line right there about where your box and whisker plot would be, right? From there, we're going to separate the scores into what we call quarter pieces, right? So this median is going to be the halfway point because half our scores are on the right of the median, the other half are on the left. And then we're going to break it into 2 quarter boxes. And the goal is to figure out, where half of the scores lie off the median. Now, if we counted, since, we take the 32 scores, we divide by 4, the next 8 scores to the right go all the way up to the score of 89, right? So that's 8 scores to the right, and that would be called the third quarter, right? So what we have here is we have, here, we'll label this, we have Q1, Q3. So the score is going to be broken into the first quarter, the median, the third quarter, and then the max, or the maximum, right? And then if we counted the bottom 8 scores from the median, that would take us to 70, right? So 8 scores away from the median is 70, right? And then the minimum score all the way over here is 55. So that's the minimum. And then we have the first quarter, the median, the third quarter, and then the maximum score was a 96. All right, so that's a box and whisker plot. In a box and whisker plot, we want to plot the minimum score, the maximum score. Those are 2 easy things to fill in. We find the median, right? That's where we're going to put that line. From the median, we count 1/4 of the scores up to get the third quarter number, 1/4 of the scores down to get the first quarter number, right? And then we're also going to be using our graphing calculators a little bit on these. Let me see if I can, hold on, I got to grab mine. Okay, so just so you guys know what I'm doing right now with my calculator, I am entering that list of 32 numbers onto one of my lists. So I'll go ahead and quit really quick. The way I got to that is I hit the stat button, or you find the stat stat function in your menu. So I go to stat, I've got lists, I'm going to edit, and then I went to list 2, and then I just start entering in scores. And so right now I'm at, next score is 68, enter, and I'm just going to keep entering the list. So all right, cool. I am done with the list. I've got all 32, and the cool thing is this calculator tells me how many objects I have in the list, which is 32. It says list 2, item number 32, 71. So I know I didn't miss any numbers. And so that's my whole list. Now the problem with this list is it's out of order, just like the weights of our dogs, right? So calculators have a really cool function for that. So I'll go ahead and quit here. If I go to, in mine, the command is stat, right? And then I have two options, sort A and sort D. It might have a different name than yours, but there's two different sorting options. If I do sort A and then I insert list 2 and I hit enter, it'll tell me sort A done, right? So then when I go back and I look at my list 2, it is now sorted from lowest to highest. So the calculator will do that automatically for you. Now the other thing it'll do is if you look at stat and you go to sort D and then I insert list 2 and then use a closing parenthesis and it says done. So if I do sort D, what that does is it sorts it from highest to lowest. So you see all the scores go from high to low, right? So that's two cool things that can help you out. Now the other thing that's most useful about putting these in your calculator is if you go to second and you go to list, right? This is the option that I was using to insert the lists, was the blue command list right above stat. It has the different list names, and then it also has operations, which is we have sorting, we have filling, sequencing, matrixing the list, and then we have math. So the cool thing is it'll tell me the minimum number on the list. It'll tell me the maximum number on the list, which are information I need for my box and whisker plot. So I can enter minimum. Whoop, clear, hold on. I'm in the wrong mode. Okay, so if I go to math and then I type in minimum and then I insert list 2, it'll tell me what the minimum is. The minimum is 55, which we already see on our plot, right? Now I can do the same thing. I can go to list, go to math, I can do maximum, and then insert list 2, and it tells me the maximum is 96, which I already have on my box and whisker plot. So typing all this information in your calculator will help you get these very easily. And then if I keep going to that math function, I can find the mean number. I can find the median number. I don't need the mean, I need the median. So I hit median, second list 2, and it tells me 81.5, which is what I had. Awesome. Now let's see here, math, median, sum, standard deviation, and then if I go second list 2, I get a standard deviation for that list as well, right? So it can do a lot of these things very, very quickly for us. And then you'll notice the standard deviation is 11.85. We could round that to 11.9. Right, and that's the standard deviation in the first quarter, and it's really close for the third quarter. Excuse me. Okay, last thing, because statistics take a while, and if you made it this far, I applaud you. So now, the reason why I put this one last is because if I put this first, you guys wouldn't have watched anything else or learned anything about the calculator. So, in stat, we have these calculations here, and we have one variable stats. If we do one variable stats, and we put it on one variable stats. So if we go back to the stat button, in calculations we have one variable stats, which if you remember is the title of our lesson. Then we have two variable stats. One variable stats, if we go enter, and then we change the list. Okay, hold on. List 2. And then I hit calculate. It gives me all the one variable stats for the list, which is really, really cool. Some of these are written in Greek, which is a little bit hard to understand. Like we have sigma of x squared. That's not so much what we're worried about. What we are worried about though is if we scroll down, we have our minimum number, which is 55. It says minimum of x, 55. Then we have our first quartile number, or quartile 1, 70, which we see is what we needed for our box and whisker plot, right? And then if we scroll down, we have our median, which is 81.5. That's what we needed for our plot. And then next we have third quartile, 89. And then last we have our max, which is 96, which will help us make our box and whisker plot. So if you sat through all this trouble, good job. Hopefully you're rewarded with this statistic option of calculating first variable stats. And then, to enter your list, it's the same way that we've been entering our lists before. And all the information we need starts at minimum of x. So that's it for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.